Good morning. Today we are going to do lesson 5C, which is line of best fit. So you guys are familiar, a line of best fit is a scatter plot. You've done these before, and it is going to be a line that best represents the data. So here are the steps that we need to follow. The first thing you have to do is you have to calculate the mean of all your x values and the mean of all your y values. And your line of best fit, that mean point that you end up getting must be on that line of best fit. So you find those mean values and make your ordered pair using the x and the y that you find, and then you draw a line that, once you've plotted your points, you draw a line that goes through that mean point but also is going in the general direction of the other points. And you want to kind of roughly have around the same amount of points above and below your line. It doesn't have to be perfect, but that's kind of roughly what you want to do. So let's go through a problem. So here we have the age of an athlete versus the distance that they can throw. So what I would do is I would use my graphing calculator and I would put your age into your L1. So when you go to stat and you do your L1, type it into all of those numbers into L1, and then you go stat, excuse me, scroll over to calc and do 1var stats. And that's going to be your quickest way for you to find the mean. And when you do that, you end up with a mean of 15 for your x. So then you go back to your stat and edit and clear that out and put in your distance thrown, which are your y values, and run that same thing. So once you have the points in, then you go stat, scroll over to calc, and do your 1var stats, and you find your y mean is 29. So that means that our mean point is 15 comma 29. And that point, once we plot all these others on there, that point is going to be the point at which you will have, or that your line will pass through. So I'm going to go to another screen here, and we're going to make our scatter plot. So let's just roughly draw this. I'm going to count by twos here. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. I don't know if I can go up anymore. I can't. So 6, 8, 10, 12, 14, 16, 22. And then we're going to count by fours going in the y direction. So starting at 2, 2, 6, 10, 14, 18, 22, 26, 30, 34, 38, 42, 46, 50, and 54. So 2, oops, that should be 26. 26, 34, 42. Okay, so we're going to plot. Our first point is 12, 20. So 12, 20. It's around there. Then we have 16, 35. And mine is not going to be too accurate, but we're just going to go with it. And then 1623 is around here. 1838. Let's see, 1327. Roughly there. 1947. It's about there. 11, 18, 10, 15, 20, 50, whoops, 17, 33, 15, 22, and the last one is 13, 20. Okay, and then our mean point we found was 1529, so I'm going to plot that point as well, and it's roughly right about, we'll just go like that. So I'm going to highlight it. That highlighted point is our mean. So the next thing we want to do is we want to draw a line that passes through that yellow point, but is got a nice amount of points above and below. So there would be one example of a scatter plot with your line of best fit. The next thing that I want to talk about is interpolation versus extrapolation. So your poles, you're going to have two different poles. They're just vertical lines that are located at either the highest and the lowest value in your graph. Interpolation is when you have values that are between those two poles. Extrapolation is when the values fall outside. So this is important when you are asked to predict. So if I am looking at this example here, my interpolation, or my poles, I should say, are going to be, this is my, that's not a straight line, but there's my lowest point, and here's my highest point. So those are your poles. And all of this area right here, that would be your interpolation. And everything over here and over here, so let's highlight it. This highlighted area and this highlighted area is what we would call our extrapolation. And that's nice when you actually get your line of best fit. When you calculate your line of best fit, then when I ask you to predict something, if it's falling within that range, inside the poles, then it's going to be an accurate prediction. But if it falls outside of the poles, it's not necessarily an accurate prediction. So let's look at another example here. So this particular example, I'm not gonna draw the scatter plot, but I am gonna give you the values here and kind of give you a rough estimate of what it looks like. So when we calculate our mean, when you plug this into your calculator and you calculate the mean, you get 30. And when you calculate the mean of your y, you get 38. So our mean point is 30, 38. And when we look at, I'm going to just kind of estimate our graph here. I'm not going to take the time. So we have and then let's say that this right here is our mean point. So here's our mean point, and then like here is our line of best fit. So our poles are going to fall right here and right here, which is right about at 5, and if I were to extend this, and at 50. So if I said to predict, so the problem said to predict the temperature of the car, which is your x, so this is your temperature, and this, or excuse me, this is your time, and this is your temperature in degrees Celsius. So it says predict your temperature of your car after it's been left in the sun for 35 minutes. So when we look at this, 35 minutes falls kind of around here, like that's 35. So when we go up to our line, that's the point, and if we were to follow it over here, it is about 35 here as well. So to predict, it's falling inside of our poles, which means that's interpolation, and so that is going to be an accurate prediction. So after 35 minutes, your car is going to be around 35 degrees Celsius. Now, after, if it says to predict it after 75 minutes, now 75 minutes is going to be way over here. And when we go up and follow our line, we're here, and it's roughly, if I follow this over, around 40 degrees Celsius. But notice that that point does not fall inside the poles, so that's not necessarily an accurate estimation, because it's an extrapolation piece of, or it's an extrapolation situation. So the first one, when we predict for 35 minutes, that one was okay, because that fell inside the poles, but 75 was falling outside of the poles. So the first one was reliable because of interpolation. The second one is not reliable. So that is line of best fit.